Hello everyone. In today's lecture, we are going to discuss about the transaction and schedule. Now, what is a transaction? Before going to the definition, let us discuss what are the steps we follow when we are designing a database. So first, when we are designing a database, we need to design a logical model of this and we represent it by the ER diagram. Now, from the ER diagram, we convert it into a relational model. From relational model, we use normalization to decompose the table into some smaller tables. Now, after that, what we do? We perform some SQL queries or relational algebra queries to insert, delete, or update data. Now, when we are accessing our data, this accessing of data is basically our transaction. So by definition, we can say that a transaction is a collection of operation that forms a single logic unit of work. So all the accessing operation or updation operation are basically make a single transaction. Now, what kind of operation? Obviously, accessing of data. Insert accessing of data means we are going to retrieve the data. Then we can insert a data or modifying a data or any combination of these is basically the operations which are included in case of our transaction. Now we are generally more interested about the reading of data and the writing of data. Reading and writing of data is basically the accessing of the data, right? Now, in case of a transaction, the database should maintain the integrity. Integrity means the database should be sound and it should be consistent. So let us take what can be a transaction with an example. Now, suppose in a bank system, Mr. A and Mr. B having an account. So amount of 100 rupees will be transferred from Mr. A's account to the Mr. B's account. So what should I do? First of all, we need to read the amount which is available in Mr. A's account. So let us take, we represent it by read A. R stands for read and A stands for from Mr. A. Now what we need to do? We need to deduct that 100 rupees from the available account. So A is equals to A minus 100. Now what will be the next step? We need to write the current amount of Mr. A's account into the database. So we write that into the database back. Up to this, what we have done, we have deducted 100 rupees from Mr. A's account. But our task is not complete. What is the part? Second part? The second part should be amount transfer that 100 rupees to the Mr. B's account to Mr. B's account. So what should we do? We first read the current amount present in Mr. B's account, right? Then we will add 100 rupees to Mr. B's account. Then the current value of Mr. B's amount will be written back to the database. Now this total thing is a transaction. And as we have discussed earlier, we are more interested in reading and the writing operation. Now, so if this is a transaction and we need to maintain an integrity in a transaction, then we need to satisfy the ACID property. ACID stands for atomicity, consistency, isolation, and durability. So let us discuss what is atomicity. Atomicity says that all the operations in a transaction should be executed or none of them should occur. What does this mean? So let us go back to our previous example. Now all the operation means all these 6 operations are there. Now suppose to maintain the atomicity, all the 6 operations should be performed. Now suppose there is a problem and we are not able to perform this last operation, the 6th. that is the writing of B to the database. So what we'll have to do to maintain the atomicity, we need to roll back or cancel out all the previous operations. So all the 6 operations need to be performed. Otherwise, if we are not able to perform all the operations, then we need to cancel out all the previous operations which is done by the transaction. So this will ensure our atomicity. The next one is the consistency. Now, consistency says what? It says that when you are performing a transaction, before the performing of transaction, a database is in a consistent state. Now, after performing the transaction, the database should come to another consistent state. So, let us understand by the previous example. Suppose in Mr. A's account, the previous amount is 500, and in Mr. B's account, the previous amount was 400 rupees. So, the total amount here is 900 rupees. Now, from the problem statement, it is clear that after the transaction, the total amount present in A and B's account should be 900 rupees because we are taking 100 rupees from Mr. A and putting that or transferring that 100 rupees into Mr. B's account. So the total amount should be consistent with the previous amount. Now, the transaction, the consistency tells us that it will ensure that in this case this consistency should be maintained, that is the total amount of A and B should be maintained. It can be, this is an example, this can be applied for any other transaction also. Now, isolation is a hot topic right now, but in case of DBMS, the isolation is basically a logical isolation. So let us take a situation to understanding the concept of isolation. Now, suppose you went to a restaurant, and when you have reached to that that restaurant, there are no other customer. So should you do? You will order the food from the menu card. The chef will cook the food, and the waiter will serve you the food. And remember, there are no other customer. Now you had once again gone to that restaurant, and at that time, there are several other customers also there. Now, will it hamper your process of ordering the food? I think it will not, because from the menu card you will order the food, the chef will cook the food, and the server and the waiter will serve you the food. Though there are several other customers are also available and they are having or enjoying their food. Now, so this will give you the idea of a logical isolation. In the first case, you are completely in an isolated situation. There are no other customer. In this second case, you are having isolation, means no other customers' operations are not hampering your operations, right? So this is the idea of the logical isolation. Now, in case of transaction, what is that? When a number of transactions are occurring concurrently. Concurrently means simultaneously. The transaction 1, suppose there are two transactions, the transaction 1 shouldn't hamper the transaction 2, and transaction 2 should not hamper the transaction 1. So this is the logical isolation or the isolation property. The next one is the durability. Durability means, as you remember, from before the transaction, the database is in a consistent state. From that, after the transaction, database come to another consistent state for maintaining the consistency property. Now, when what is the durability says? It says that when a transaction make some changes on the database, the changes should persist, means the changes should be permanent until and unless another transaction made another changes. So whatever the situation, the system may fall, any physical phenomenon or natural phenomenon, or the system may crack down. All the changes what they have made should be there. What a transaction made should be there. Now, if there is no durability after the transaction, suppose in this case the amount in A's account is 400 and amount is B's account is 500. Now, suppose the bank system is crashed. Then, if there is no durability, then bank may say that no, we do not know about this transaction because our system has failed and A's account there is 500 and in B's account there is 100. That situation shouldn't be there. We need to ensure the durability. Means the changes made by the transaction should persist or should be permanent. Now, so each and every property, that is atomicity, consistency, isolation, and durability, is maintained by some subcomponent of DBMS. As you all know, that DBMS is a software itself. So there are some subcomponents which ensure these four properties. Now, atomicity is ensured by transaction control subsystem. Isolation is ensured by concurrency control subsystem, and the durability is maintained by the recovery subsystem. If you go through this all atomicity, isolation, and durability, you can see that the consistency is basically the result of these three. So the consistency should be ensured by transaction control subsystem, concurrency control subsystem, and recovery subsystem. Right? Now, this is called the acid property. Next, we are going to discuss about the different states or stages of a transaction. So, state of transaction is when a transaction starts, it remains in the active state when it is performing reading and the writing operation. So let us go back to our example. So up to this, the transaction is in the active state. Now after that, when all the reading and the writing operation has been done, then the transaction moved to a partially committed state. What is a partially committed state? Partially committed state that the transaction, all the reading and writing operation has been done, but the final result hasn't been committed or written back to the uh, final result hasn't been saved to the database, but the reading and writing operation has been done. When the commit operation, when the transaction is when we commit the transaction, means finally we save our transaction result into the database, we moved into the committed state, and this is from active to the committed. This is a consistent state and this is a consistent state. Up If the transaction is not committed, we can say that it is not in consistent state. Now after that, the transaction can be committed. Now, maybe for due to some reason, for due to some system failure or any other reason, the transaction can be stopped at the active state. Like in the previous example, suppose the transaction has stopped to the system failure in this state. So from active state, we will move to failed state. So we need to abort all the previous operations performed in the transaction. Now, from partially committed state, we also can go to the failed state be- because we haven't committed the transaction yet. So, From partially committed state, if we are forced to move to the failed state, then all the previous operations of the transaction, like from these, and these, all the six operations need to be aborted or rolled back, and from this failed state, we will move to the terminated state. Terminated state means the transaction is over. So there are two different possibilities in case of a transaction. From active, we will move to the terminated, we will move to the committed state, and from that we can terminate that transaction. Or if there is a failure in the active state, if there is a breakdown in the active state, we will move to the failed, or in the partially committed state, if there is a problem, we will move to failed state, and then the transaction will be terminated. Now, so this is all about the basic idea of a transaction, the acid property, and the state of the transactions. Now, in the next lecture, we are going to discuss about the scheduling.